Chapter 6 review for the final exam. If you recall, Chapter 6 is looking for area under that normal distribution curve. So the normal distribution then has this idea that within one standard deviation, or one step above and below, you're going to have 68% of the data. Within two steps, or two standard deviations above and below, you're going to have 95%, and three steps above and below, in the tails, you will have approximately 99.7. So if it's a normal distribution, it's going to follow this pattern of 68, 95, 99.7. It is symmetric, meaning that right down the middle, it looks the same on both sides. It has tails on the outside edges, and sometimes we call it a bell curve. But the formal name for statistics is a normal distribution. Not all things are normally distributed. We like to standardize things. Standard is what we measure off of. It's a standard that we put everything onto. We do this through what's called a linear transformation. We just shift this curve so that mu, the center, is going to be at 0, and my standard deviation is going to be a size of 1 or 1 step. And we do this so we can use the table out of Chapter 6 in the book on page 407. A standard score is the score that I'm going to use on my standard normal distribution. The standard score is the number of standard deviations or steps you are away from center, or mu. So if you are looking at a normal distribution, and here is your center, and you are negative 2.8 standard deviations below, we call that a z-score, and that means your location is about 3 steps below center. And now in order to find this score, there's a formula that we're going to use for the standard score, and it is called our z-score. Z for standard score. And the z-score is find out how far away you are from center, how far is your single observation away from center, divided by the standard deviation. This will tell you the number of steps, the measuring stick, standard deviation, you are away from center. So if you were trying to find these areas or where you're located, if you were looking to the right, and I keep drawing this picture here because you'll want to be able to draw that. If I'm looking to the right, suppose this is my z-score, the area to the right. So what I need to do is take 1 minus my standard score out of the book. So 1 minus the table value. And we take 1 minus the table value because we're reading to the right. The table, however, itself finds the area to the left. So if I'm here and I want this area, I just get the value out of the table. And if I'm looking for a between, so again, we'll draw a curve. If I'm looking for a between, and I have my standard score, z-score, up here, and I find the table value, it's all this blue. If I wanted to stop it here, so I only had this common area, I would take the value from the blue, so it'd be the blue value in the table minus the red value out of the table, because the red value is this extra piece here that you want to subtract off and not have if you're looking at a between problem. The center of a normal distribution is mu. The area under the normal distribution is 100% or 1. That means if we're using this as our model, we're going to say that we all fit underneath that curve. That's why the tails never completely close. This notation, a capital N for normal, before a capital N meant the size of the sample, the size of the population if it was capitalized. So you got to kind of look at what you have here. Mu is the mean of the population, and sigma is the standard deviation of the population. The mean of the standard normal just says mu is going to be at 0, just like we knew that the standard deviation of my standard normal was going to be 1. So if I am 1 standard deviation above and below, this area here is 68%. That comes from the empirical rule. If I am 2 standard deviations above and below, look at it, almost covers all of my curve. In fact, it covers not 68%, it covers more. It covers 95%. So we're counting our steps of size 1. So 1 is equal to my standard deviation. The properties of the standard normal distribution, again, you're looking at that bell-shaped curve. This is 0, and we're looking at step sizes of 1. So when I count up, it's 1, 2, 3. And when I'm below, it's negative. A negative z-score says that you are just below the center. If you look up a z-score on page 406 and you find that value, what does that value mean? Well, this is why I like to draw pictures. That value, 70.54, well, if this is center, we know 70%'s got to be higher than 50. So we know this value means that 70% approximately, because I rounded that, 71-ish percent, of 30-year-olds, because that's what we're talking about here is 30-year-olds, what about them? Have a heartbeat let's see, is lower than 72 beats. So if you have a heartbeat of 72, it looks like you're kind of on the high end because only 30% have a heartbeat of 72 or more extreme than you. So you're a little higher than the 50% or the average. And in this case, we're looking at a between problem. We're generating garbage. So again, we fit this normal distribution. The standard deviation is 2 pounds, and the average of this is supposed to be 28. So if you generate 27, you are down a half in terms of steps, because remember this would be 28. So 27 is 1/2 of a standard deviation below center. And 31 is going to be above. So 31 minus 28 is 3/2, which is 1.5. So 31 then is up in here. So what you want to do then is find the amount of space that lands in this area. So if you recall what you do, you need to look up the 1.5 in your table, and what that's going to give you is this space. So you're on that page 407, looking up a positive 1.5, you should get a value of 0.9335, and if you want to round that to 93%, that's fine. And if you recall, that's too much. I want to take this section off, so I only have what I want that's in the center. So I'm going to subtract off, looking up 1/2 of a standard deviation, and 1/2 of a standard deviation is about 31%. So I'm just going to round this to 93% minus 31% gives me 62%. So this is 62% because I knew that this was 31%, and this whole piece was about 93%. So that's how you find area between, and the previous problem was finding area to the right. So that's a review of Chapter 6. It's reading the table and knowing what a z-score is. Chapter 6 comes from looking at a single observation.